Hello everybody and welcome to PASS's Excel Business Intelligence Virtual Chapter. We're very excited you could join us today for Jordan Goldmeier's session, Creating Outstanding Spreadsheet Models. This webinar series is brought to you in partnership with Excel TV and actually features 4 back-to-back sessions presented by Excel experts and host of Excel TV. Go back on one slide. My name is Thomas LeBlanc, and I'm the virtual chapter leader of the Excel Business Intelligence Virtual Chapter. I have a few quick introductory slides before I hand it over to Jordan. He will speak for about 40 to 45 minutes, and then we'll move to a Q&A where you can ask some questions you may have. For technical assistance, you're going to want to type your question into the question pane. It's located on the right side of your screen and someone will assist you during the session. This question pane is also where you can ask questions throughout this presentation for Jordan. Feel free to enter your questions at any time, and once we get to the Q&A portion at the end of this session, I'll read the question to the speaker so he can answer it. You're able to zoom in on the presentation content by using the zoom button located at the top of the presentation window. Please note that there'll be a short evaluation at the end of the session. Your feedback is very important to us, so please take some time to complete it, and it's going to appear in your web browser at the end. Today's webinar series is brought to you in partnership with Excel TV and the PASS Excel BI Virtual Chapter. Excel TV is a live broadcast where Excel and analytics are discussed in a casual format. Join the host for topics, tips, and news related to Excel every other Tuesday at excel.tv. The Excel BI Virtual Chapter features sessions on everything Excel Business Intelligence related, including advanced predictive and prescriptive analytic topics. Please join us this Thursday for Devin Knight's session using Power BI parameters and template. You can register online. If you look at the bottom right, it's excelbivc.sequelpass.org. And now here's Jordan.
Hello, everyone. Thank you very much, Thomas. Thank you, everyone at PASS, for helping us put this on. This is a great partnership. So I'm Jordan Goldmeyer, and I am the Chief Operating Officer at Excel TV. So I'm very excited to be here and talk to you about great things with Excel. And, of course, thanks again for joining me. I know that this is a very busy work day for many of you, but it's great to come out, or it's great to have you here to learn for an hour or more if you've signed up for more. So thank you so much for being here. So as my regular day job, I am a Senior Insight Manager and Data Scientist at DataKind. If you've not heard of DataKind, they are a nonprofit that helps other nonprofits complete data science projects. So a very cool organization, a lot of great projects. I'm also the owner of Cambia Factor. That's my own consulting agency through which I consult, speak, and do all sorts of things. So I'm also the author of Advanced Excel Essentials and Dashboards for Excel. You can find both those books on Amazon, and they're published through A-Press. And I've also just been in this business for a while, doing analytics and data science work for the Department of Defense, and I also teach for the University of Cincinnati multiple times a year. They have a 2-day Excel short course. So enough about me personally. But you can find me on Twitter. That's at Option Explicit. So for the folks of you who do VBA out there, hopefully you get that. And also at Excel TV. And you can also find me on LinkedIn. Feel free to search me if you Jordan Goldmeyer, or you can take down that link. And also we'll follow up after this presentation through Excel TV to let you know where you can find us. All right, so on to the presentation, the main event. So it's called Creating Outstanding Spreadsheet Models. So what does outstanding mean? Does that mean better than your peers? Well, maybe. Does it mean very good? Well, sure, it means that. But what do I really mean by outstanding? So let me frame this current problem before I even move forward on this presentation, because I want to explain why the things I'm about to say are actually very important. And here's what I mean. Right now, if you're an Excel developer or someone who's using Excel within this space, you know that there is some competition with Excel. And by competition, I'm talking about big BI platforms. Things that say, hey, we can do what Excel can't do. And the usual arguments are, well, Excel is slow, it's buggy, it's an antiquated piece of software, and to a certain extent, these arguments are not wrong. And the way that we've often built models in the past, we've actually created work that is buggy and that is slow. So what I've done here is set out a list of principles that I believe, based off my experience, you should follow, or one should follow, to create better models in Excel, to create things that are faster and quicker. Now, here's the thing. You may not agree with all of them. You may agree, let's say, 60 to 80% with them, and that may be because 60 to 80% of what I do is very overlaps with 60 to 80% of what you do. So what I want to ask you to do right now in thinking about the future is, in that last 20 or 40%, what are things that you could do differently? So keep that in the back of your mind as you walk away from this course. So not just have a learning experience, but maybe an exercise after this course and think, well, what are things that I've done that's been convention that maybe I've wanted to do differently, or I've thought about differently, or I thought I couldn't break convention because people said I couldn't do them differently. I really want to help us right now to create better spreadsheets because we do need to beat back those vendors. And if it were up to the vendors, well, let's say this: the three V's of big data for me are vendor, vendor, and vendor. So for me, this is a really important moment for us Excel developers to really show that we can actually do things that are cheaper and better and faster and cost less money without having our team or organization bring on this giant platform. So how are we going to do it? Well, I've divided my principles down into really three different buckets. And you may say these buckets overlap, and that's fair, but really we're going to use them here for convenience. So the first is layout and design. And by layout and design, I mean easy updating and error mitigation. So by easy updating, I mean not creating something that requires a lot of VBA to update, and you'll see how we can get around that here soon, but something that is actually very easily updatable. And when I talk about mitigating error, what I mean is that we try to minimize the appearance of errors, and later we'll talk about when there are errors, we actually want to be able to see them. So we need to create a layout that helps us do that. And then finally, clip art, distracting company logos, word art. I don't have to sell this too hard, but these sort of things have no place in our models, and we'll talk about that here as we go forward. So mechanics. Mechanics deals with formulas and code. So what I propose with mechanics is that we should be creating simpler formulas. So one example I'm going to be using is the nested if, and we'll talk about how nested ifs get both complicated from the standpoint of trying to understand them, and also they can get complicated in general. They're often the hammer that sees everything as a nail. And finally, we're going to talk about data visualization presentation. It's no longer enough these days to just be good at development with Excel. We really need to understand data visualization and presentation. So the good thing is that despite what you might hear, the data visualization field is not terribly huge, and it's actually not terribly hard. So we'll present some data visualization topics, and I'll give you a link at the end that has a resource for one of my favorite data visualization gurus, Stephen Few. Now, not everyone agrees with him, but definitely a great site to look at to learn more about data visualization. But the point here in all of this is that we're trying to minimize embellishments, and we're trying to make work that's easy for us to understand, both in the moment and later when we pick it up. So I always have this in the slides. I say what to know, and also why we should want to know it. So first of all, let's talk about what a model is. So when I say model, I'm not just talking about a regular spreadsheet. I'm talking about using Excel as a simplified version of reality. So that means budgeting, that means prediction, that means taking a process and turning it into a model so we can view it as a dashboard. So anything that takes real life and distills it down, and we use the spreadsheet for, that is a model. And so when we use a spreadsheet model, we're trying to understand and capture and make predictions and really capture this simplified reality such that we can we can have a better understanding for our decision makers. And so why would we want to use spreadsheets at all for this? So when there's so many BI platforms out there right now that promise to do push-button analytics, the answer to that is that they're ubiquitous. They really are everywhere. You can create a spreadsheet on your computer, and you can send it to your colleague, and chances are they also have Excel, so you don't have to worry about that. They're relatively cheap. So even the Professional Plus version of Microsoft Excel becomes cheaper through Office 365, but even that Professional Plus desktop standalone, I think it retails for $400 some. That's still a lot cheaper than things like Tableau, which typically retails for $1,000 a license, and that's still even on the low side compared to others in this industry. So that's one good reason to use spreadsheets. Another reason, and this isn't really in here in full, but I just want to promote it before I move on, is that right now when you spend a lot of time, money, and effort and resources into a platform, you're less likely to turn your back on it. So we think of something like the housing market crisis, right, where a lot of time, money, and effort and resources were spent into developing these models that we found out were later not really reflective of reality. But it's very hard to turn your back on something when you've put this much resource, I call this the resource bias, into it. So why should you use spreadsheets? Because they're so cheap. So you do not need you don't have this time, effort, and resource problem. So some problems are way too big for Excel, but you can still prototype in Excel. So this is why it's a good idea to model in this tool. So here are our goals that I'm going to lay out for what we're trying to do with our outstanding spreadsheets. The first is development memory. So what do I mean by that? Well, as you create enhancements and as you code with either with VBA, we won't talk about VBA here, but still with VBA or with formulas, there's a way of working with formulas that you encode what you're working on. So a nested if with that just references cells, it may not be entirely clear what's going on, but there are things you can do to make it easier. So the reason why you want developmental memory is not just if you have to pass it off to someone else, and we all know that we receive work from someone else or we have to pass it off, but there's another person you might pass it off to, and that's you. 6 months to a year from now, or maybe even 2 or 3 years, you're going to look at it and say, what the heck did I do? So encoding developmental memory, programming in a way, or treating your spreadsheet in a way that encodes what you've done is very useful when you have to come back to it. The next thing is model transparency. So that is the degree to which you are able to understand the underlying methodology. In the way that I'll argue that we should build, transparency is very obvious. You can figure out where errors are. And if someone says, hey, what's going on, you can unpack it. And finally, model efficacy. Efficacy really refers to the belief and the confidence that what you're doing or what you promise your model can do, it actually does. So we often forget about this. We develop in a very rote, mechanical manner. We don't trace what we're doing to some effect. But really, it's our charge as analysts to make something that we're confident in. So efficacy doesn't just refer to being correct, but also encouraging the belief of your audience that the work is correct. And I'll show you how you can do that. So let's start with layout and design. So I'm a big stickler on this. Following good naming style. You may not think that that's part of modeling, but it's a very important to version control, as we'll see. I am very big in saying using clear and descriptive names, avoiding acronyms, things like that. We also want to implement good model layout, and I'll show you what I mean by that in the next few slides. We want to use worksheet tabs judiciously. Often what happens is we separate our analysis across a bunch of tabs, and besides that becoming problematic into what we've done, it increases the bloat of the spreadsheet. We also want to keep formats organized and clean. We've seen spreadsheets that have tons of formats on them. Those formats add weight. They make things slow down. When your spreadsheet is trying to crunch a lot, you should ask yourself, is the main purpose of this spreadsheet to have these formats, or is it to answer a question? So use formatting judiciously. Use it where it's needed. Do not include it where it's not. Also, include only sufficient instructions. So I'll talk about that a little bit. That usually goes against the grain, and I get a lot of pushback from auditors on that. But I'll explain to you why on that. So here's the file name checklist. The things you should do is use complete words. You should abbreviate proper nouns, and you should connect words with a space. Don't connect words with things like underscores or dashes. You don't really need that. So that's kind of a leftover of our IT world where we couldn't use spaces and we couldn't use those things in file names. So I guess what I'm saying is, as you develop files in Excel, and I'll elaborate more on this in a second, try to use something that's very clear so that you understand it later and it doesn't look like an engineering variable. So stay away from incomplete words, jargon, abbreviations for the sake of it. So we see something that might say demo. Someone might write DEM instead of DEMO. I'm not sure why. It's not that much extra, but try to be very clear. Don't mash words together without a space. And if you are going to use dates, make sure that they're delimited, that there's separation. Don't use them without delimiters, because then they turn into this series of numbers, and we don't quite understand that. So what I'm saying, and you can hear this theme, is that as we're developing, we should be very clear and encode what we're trying to do. So in the top image that I have shown here, I have a series of dashboards that someone has made, and they've left on different dates, and they've left, you can see there's this when they copy something, there's that parentheses one. This is often what I see in folders, and hopefully some of you are nodding, looking this, or hitting your heads and saying, oh God, I hate looking at this lack of version control. So if I asked you to look at this top image and just take a second, could you figure out what the latest version of this file was? Well, I'll help you out. The latest version is this sales dash, April 3rd, 2012, and you see that there's been an update to it and that someone has put a B there. So that's not a very good way of doing version control. And what I propose, and some people have pushed back against, but again, still important to think about it, is just to add numbers to the end. And this is how I like to do it, because when you look at it in the project folder, first of all, if you have the details showing, and you can have the date modified, and that's going to tell you when it was last saved. And then finally, no matter whether it's sorted ascending or descending, you immediately see which is the first and which is the last. And actually, that's a very important part of data visualization. So this type of dynamic, for me, makes it a lot easier. So I'm not going to be so prescriptive and say, you must absolutely use this, but I will have you all look at this and say, isn't this a better way than the previous way? How can you make it better in your own, following something like these principles? Now, you may be thinking, well, file names, who cares? Well, another way in which these naming problems creep over is in worksheet tab names, and here it's far worse. And we see this all the time where a series of colors and capital letters and lowercase letters and underscores pervade the tabs. And what I argue is simply to just use the tabs and use English words down below that simply say what you're trying to do. So here, this is very common in my work. I'll have a menu or an overview or an opening. Usually I'll have the dashboard, I'll have a calculations tab, which we're going to go back to because you'll see where that calculations tab comes in, and I usually have a raw data tab or a database or something like that. I may hide them, but I try to condense everything down and try to be descriptive as possible to the next person who's going to look at it. So here's how the previous tabs map in. So I argue proper model layout follows this dynamic, which for some of you may notice that it's very similar to n-tier architecture, but usually you have information, and that's where your back-end data resides. You have some sort of transformation. You're going to do something to that data. You're going to perform calculations on top of it. So we all know the rule, never touch the raw data. The transformation does something to that information. And finally, we have a presentation layer that shows the results. And in fact, we can see this in practice. So here I have some information. I'll apply some type of pivot table to it. That's going to be the transformation, and then finally we have a presentation, which is, so those results will inform the presentation. Sometimes pivot tables act themselves as the presentation layer. I generally argue against that, but it's okay if it happens. It's okay because it still sort of fits into this dynamic where the pivot table is doing work on the raw data itself. Now, why would you ever want to do this? Well, there's this idea of error transparency. And the reason I like this is that, let's say there's a problem in my presentation layer. I see something that's an error that doesn't look right. So I think, well, how did I get there? Well, I can take a step back and I look at the transformation layer. And if the problem is still there, I can take a look and I can see if it's at the information. So let's say I do that. I look at the information and I see there's no issues here. Well, by deduction, I've now realized that the problem has to be within these calculations here. And in the same vein, let's say there's a problem with the presentation layer. I go back to transformation. I don't see any issues. It all looks good. That means that the problem, the error that's happening, is probably happening at the presentation layer. So using this dynamic and having very clear-cut areas in which you perform analysis, or I should say in which your analysis flows through, is very, very useful. And if you make this formula-driven, which I generally argue you do, so I often stay away from pivot tables for this reason. So this transformation layer uses a series of formulas that pulls from this information, and the presentation uses formulas and charts that pull from the transformation. That means as you update information, as you update your database, all of that is going to naturally flow through and immediately flow through to the result, to the presentation. So in a sense, your model is living. So I really, really, really like that dynamic because I can make changes to the back-end data and it will automatically be reflected in the presentation. There's no run button or OK button or go button that has to turn on worksheet protection or flip it off. There's very little VBA in this. And don't get me wrong, I'm not against VBA, but In this case, in modeling, I try to minimize it as much as possible, at least to the extent possible. So why does this even matter? So what I really like about this is the separation of concerns. So we keep the transformation layer separate, and we keep the presentation layer separate, and we understand that it sort of flows from one end to the other. That means that the presentation layer is not going to mess with anything in the transformation. And it helps us clearly understand what areas of the spreadsheet are doing which. And I'm going to just jump back real quickly. So that's what I generally do. My dashboard is my presentation, my calculation is my transformation, and my raw data in this case is the information in the back. So that's how I like to set it up. Auditing transparency on why this even matters. So being able to audit your spreadsheet is very, very important. I don't have to sell that to you very hard. I feel like within this dynamic, auditing is much better. Error propagation, I talked about this a little bit. It's very important when you have errors that you see them, right? Often what happens in these BI platforms is there may even be an error in their code, or there may be an error in the way it connects to the database. We don't really know until it gives us results that don't pass the smell test. And often what happens is when the results are funky, management says, oh, well, we have some counterintuitive result, but that's what the data say. No, we do not want to operate in that way. We want to make sure whatever errors happen, they immediately present themselves, because that's the only way we can deal with them. And finally, this preserves the integrity of the back-end data. So the raw data stays raw. You're only going to be doing work on top of that, and then you're going to be presenting what that work is. So in the next part of clean and organized layout, I'm presenting what I often see are the dashboards in management and in companies. And you can see that there's a lot going on here. There's a lot of gradients, there's a lot of formatting, there's a 3D chart. We'll talk about why 3D is terrible later. There's a big byline here, and there's clip art that's not useful. So take a look at this and ask yourself, is this really as good as this alternative? I will posit that the latter one is a lot better, and that's because it helps deliver the message quickly. Remember, the point of a spreadsheet is, the point of your spreadsheet is not to put on art, it's not to sell yourself, it's to deliver a message to decision makers. And this is just something else that I will say annoys me, so I'm just going to present it here. And that is, again, what data visualization research tells us is that when we display information, we should be keeping the baselines flat, and I'll even prove that to you, that it's better and easier to understand near the end of this presentation. So on the left, we have what I commonly see. It's not a particularly offensive example, but it really should look like how it looks on the right. We should be presenting data in a clean and organized way. If you're saying we don't have enough room for the titles here, well, it might be time to really to guess, or I should say, it might be time to return to those titles and ask yourself if they need to be that long, or perhaps use word wrap. When you have really long titles that are at an angle, we know because of data visualization research, it says it's less easy to understand and comprehend. And then I'm going to put this in terms of charts. We see the one on the left has a lot of color to it. It's not entirely as easy to understand as the one on the right. So a lot of people ask me, well, what's the correct way to present data and do data visualizations? At the end of this, I have a link to perceptualedge.com, Stephen Few's site, to research more on that. But really, the research tells us that we should try to minimize the non-data ink. So that's the part of the chart that really doesn't help us display. So you may look at the one on the left and say, well, big deal. It's not that hard to read. And in truth, you're probably right. This was a very easy example I created for this presentation. But we all can actually harken back to a moment in our own professional careers where we saw charts that were really, really too much. So what I want you to do in terms of going forward is just think, do I need these elements on my chart? Am I helping the reader quickly understand what's going on? So why does this even matter? Well, extra images and embellishments, those things that seem innocuous that you put on your dashboard, those actually harm your file because they make it bigger and they make it bloated, and they don't really contribute to anything. And when I say they make it bloated, if you have a very heavy calculation, it does take up that memory. It does make it slower. So there's a lot of good reasons and advantages to minimize that Excel file size, and it can be done. When I worked at Ernst & Young, I was handed a model that was just so ungodly big. And using these principles, we actually got the running time that was 5 minutes down to 30 seconds. And that's because I removed all these embellishments, among other things. And we took the file size that was just megabytes down to less than a megabyte. So it can be done. If you remove the embellishments, it really does help. And the second part of this is just presenting without distraction. So again, we all sort of seem to understand this, that we have a direct message that we want to convey, but often we create our own distractions using formats and things that don't necessarily need to be there. Data visualization generally decreases our comprehension. So it may impress people. They may say, oh, this looks sexy and this looks good, and clearly this is complex, so whatever you did must be complex. But in reality, we know that presenting things that don't follow data visualization research, or that are overly flashy, I should say, don't really aid in our decision making. And then finally, this is something that I do spar on with a lot of people, but I'm just going to present it to you to munch on, which is to keep those detailed instructions out of the spreadsheet. So small instructions are okay, telling the user what to do, what to click on, that's fine, but those big instructions are the exact same problem that I described with clip art and embellishments. And I have an example over here of one that I often see, which is there's an instructions tab and it has everything on it. Now here's the funny thing, Excel is not a word processor, it's not designed to give you instructions, so put those in Word, and even better, use those links in Word and then create a PDF out of it, and now you have a table of contents with everything linked, or you can also do that in PowerPoint, which I like to do if it's a more visual instruction. All of this just increases the file size, so remember, we want to keep things at a minimum that are not part of delivering the message. So next up is the mechanics. This is our second bucket. So I argue you should design for readability, and I'll show you what that means here in a second. You should root out spreadsheet errors. So a lot of times we keep those div 0 errors on our spreadsheet because a certain cell has not been filled in by the user. Those do really slow things down. They grind your spreadsheet to a halt. So if you have errors in them, remove them. And you should also avoid volatile functions. So volatile functions are things like offset, today, now, indirect, which is unfortunate because it's a great function, but those really do slow your spreadsheet down. They require recalculation, and we'll talk about those in the next few slides. Avoid complex ifs, and finally use natural formulas. What does that mean? It means formulas that naturally reflect the underlying problem, and in that way we can encode development memory. So in designing for readability, one of the easy things that we can do, especially for complex nested ifs, which I have to admit are sometimes unavoidable, is use the Alt-Enter in the formula bar. So here at the top, I have a formula that has no spacing in it. Down below, I've hit Alt-Enter after that first if condition, and then I can use space to tab it in. So if you've done some programming before, this is probably very natural for you, and if not, it's okay, it's very easy. So you'd hit Alt-Enter and you hit space to bring it in, and you can see that this second one is far easier to read and even understand than the top one. So a very simple tip, just use Alt-Enter. The next thing you can do is use a named range. So the very easy way of assigning named ranges, and named ranges allow you, instead of referring to a cell address, to refer to a name that you've given it, and it doesn't even matter. If you move that cell address with the name assigned to it, it will always stay updated, so also a great reason to use them. You can assign them by selecting a cell, and over in that name box, which is next to the formula bar, type in a name. And here, as I have this sample, I say if the droids you're looking for equals false, then move along. Now, if you catch the reference, and hopefully you do, that's actually very important because I've encoded what I was trying to do with the problem within the if formula. So the if formula does not stand by itself as some mechanical thing. I've actually put something in there that helps us understand what the problem is doing, and that will help me understand it later or when I have to explain it to someone else. The next thing you can do is root out those spreadsheet errors. So the easiest way, and I'm not going to judge your spreadsheet errors in your spreadsheet. I know how it is. You develop something and sometimes you forget, and they just sit there. They're artifacts of a previous analysis. So you need to find them, and the way to do that is you can go to Find and Select from on the Home tab. Under that, go to, and you'll select Go to Special, and in the dialog box you can select Formulas and Errors and hit OK, and it will highlight them and help you remove them. Another alternative is to use if error. So if error, you put the formula that you expect to have an error. So let's say there's something that's going to be a div 0 because the divisor has not been input yet. So you can always just put that formula surround it with an if error function and put it in that first parameter, and then the one that returns you can write an error has occurred if you're expecting the error and you want to do something about it, or you can say something like that data has not been input yet. But the point is that you can handle it. So if you handle it, it won't slow your spreadsheet down. I will say that there is a word of caution here, that we want to make sure that we do see errors and do something with them. So if error, you should use that when you know it's going to result in an error. You should not use that to avoid dealing with errors or to obfuscate or mask errors as they come up because you don't want the user to see them. So you need to be able to see them and deal with them. Volatile functions are functions that will recalculate no matter with every volatile action on your spreadsheet. So volatile actions are changing a cell, adding, inserting a row, changing the size of a cell, really using the spreadsheet in general. So things like indirects do not recalculate, some does not recalculate, but volatile functions always recalculate. So some of them make sense, like today and now, so we always want those to recalculate, right, because we want to know what this moment is or what the day is. And there's ways around that. You can use VBA, and in this case, having VBA right is probably a better solution, but you can judge that for yourself. In the case of offset and indirect, these are both lookup functions, and I would argue that you should use index instead. Index is easier, it's much faster, and it's non-volatile. And indirect is unfortunate if you use that because it is actually a very useful function. But I will acknowledge here, as I always do, you can't always get away from them. So my argument to you is to minimize them. So try to mitigate them as much as possible. If you have to use one, don't use it for everything. Try to use index as much as possible. And then next, I want to talk about natural formulas. So here's an example from Microsoft Excel Help, which is the nested if. And in this case, they present a series of grades. So we all know the grading system. A's are usually 90s and above. B's are 80s and above, C's 70s, and so forth. So the nested if example that they're trying to do is say, what grade did this person get based off of this input? So here's the thing. Here's my argument to you. Is this a good use of a nested if? And if we take a look at the problem, we really think about it, I would say that it's not. In fact, this is a natural lookup problem. We should instead be using something like match. So here I have the current score input, and then in cell B9 I'm using match to match its location, and then finally in cell B10 I'm using index. So why would you want to do that? Well, if we think in terms of the problem, is the reason, let's say I get a 78 and I have a C, is the reason I got a C because I didn't get a B? Well, not really. It's the reason I got a C because I didn't get a D. No, not really. No, we are dealing with scale problems, or I should not scale. We're looking for lookup problems where we're falling within a certain range. And here, match and index do a much better job. They do a better job intuitively. We understand it. It isn't a case in which we need nested ifs. Now let's think of another problem. So here I have product IDs, 1, 2, and 3, and I have an item size, and I want it to return small, medium, or large. So I have an input of a product ID in cell B6, and here in cell B7 I use a nested if, which in cell C7 I show you how I've done that. And you can see, again, this is sort of a problem because we have this small, medium, and large being returned, but this doesn't necessarily make intuitive sense in what we're trying to do. This is an ordinal scale here, so that means that even though we're using discrete items, there is some natural order to them, small, medium, and large. In this case, choose is a much better option because here I can put in 1, 2, or a 3 in cell B6, and if you've never used choose, the way it works, if I put in 1, it's going to return a small. If I put in 2, it'll return a medium. If I put a 3, it'll return a large. And actually, it will do that and so forth up until 255. In the keen observers, I don't know if any of you noticed this, I wrote small, medium, large. I probably should have used these cell references here instead of the quotes. But it does drive the point home that the latter here in cell B8 actually more matches the problem of what we're trying to do. It matches the 1, 2, 3 dynamic, and it naturally follows that order. So here's the thing. I'm not going to argue you can't use nested ifs. I use them all the time. But here's what I'll say. You should use nested ifs when the problem naturally lends itself to a branching condition. Now, what does that mean? Well, in short, you can make it very easy on yourself. Can you draw a flowchart naturally from this problem? If you can, great. That's a great nested if problem. If not, probably isn't. And another way to do that is to start from the result and work backwards. Is the reason I got an F because I didn't get a D, because I didn't get a C? Not really. So if we're able to say yes to those questions, then yes, we do have a branching compounding condition problem. So what I would say not to use is use ifs as a hammer where everything's a nail. And then if you do have to use nested ifs, you should probably not use more than 3. And I don't just pull that out of nowhere. What we know about our working memory is that we can store 3 to 7 chunks at any time. So if you're trying to analyze something, trying to relate it back to the problem, beyond 3, you're going to start taxing your working memory, your short-term memory. And finally, don't write ifs that only you understand. Keep yourself, the future you 6 months from now in mind, and keep your friends in mind and colleagues and coworkers who will have to look at it. Now finally, our third bucket is data visualization and presentation. So we shouldn't mislead with charts. This is really one of the things that the BI vendors say that we often do. Our charts are not good enough in Excel, but often their charts are misleading. So let's be better than they are. We should avoid data occlusion, and that's a way of presenting data that actually doesn't show it, which I know doesn't make sense, and I'll give you an example here. We should always show relevant data together and not move it piecemeal around the spreadsheet. And you should learn some data visualization principles. A little bit actually does go a long way. And finally, we need to respect our audience's intelligence. And that means we don't present things to them like they're in 5th grade or in 6th grade. I know we often hear that, or 2nd grader is the example I hear, but we use this example of various young ages, explaining to them like they're dumb. No, they're in a position for a good reason, and you should explain to them to the intelligence level they understand. So just taking a look at some misleading charts here. On the left-hand side, I have vote results being displayed, and I have the same information being displayed on the right. So just take a second and look at these and decide for yourself which one is better. So according to the research, the one on the right is better, and here's why. Because the one on the left doesn't start at the 0 axis. So whenever you display column chart data or bar chart data, you need to start at the 0 axis. And you can see the differences here are not very significant on the correct vote results. But as we look at the one where it's wrong, we visually overstated that difference. And in many ways, that's how we are lying or misleading with charts. And here's just a very common example to show that this does happen. It happens within our news, does it all the time. So let's try to be different and try to be the difference in that sense. So let's talk about 3D here. So let's take a look at this pie chart. Which slice is greatest to you? We probably all hopefully said yes. How about now? Well, now it looks like that red one, the no, is greater. And how about now? Well, if we remove that 3D, we actually see that they are the exact same. So this is hopefully a reminder to you that just because you present data, the way we interpret in our minds may not necessarily be connected to the message or to the data itself. So we need to always message the data to our understanding, or as I like to say, what we present should always be a natural extension of the underlying problem. So data occlusion, this is often a problem in 3D charts. If I said, what is the value for product C sold by the 4th representative in region C, it's not very easy to see here with this chart, and yet we see 3D all the time, and this is one of the big problems of 3D, is that it occludes, this is data occlusion, it occludes from view important data points, and if we're looking at this, we're trying to do a comparison, and yet we can't because the colors also blend in with the 3D effect. So this is a good example here, or probably a terrible example, I should say, of using a chart incorrectly and presenting data incorrectly. We should not remove from view important information that would allow us to actually do what the chart was designed to do. So stay away from 3D if you can. We should always try to show relevant data together. So what do I mean by that? Often it's the case that we take data and split it up, let's say, by years here. So I have data and I have all the years here, and what we'll often do, and especially people will say things that are, they'll create spreadsheets and they'll call them dashboards, where each worksheet tab has its own chart. So remember, each worksheet tab is additional bloat, and also remember that when we try to understand things, we need to understand them together. So to the extent possible, as you present information, always try to show it as one. Don't split it up in worksheet tabs needlessly. You don't necessarily need to do that. And I would say follow the dynamic that I presented earlier, which is information, do your transformations in another tab, and then present it in the end. So one of the ways in addition, that we can actually get around showing data apart is we can use things like sparklines. So if you have a concern that there's too much data being shown here and you need a big chart, luckily Excel 2010 and beyond has sparklines that can summarize this data in a very small amount of space. And again, just to drive this point home, this is a typical dashboard. Often people will take these individual pieces like the sparkline segment on the left and the total tornadoes per year on the right top and the one below by month. They'll split them up into different worksheet tabs when that's not actually necessary. What helps in our understanding of this problem is to see it all together. And finally, I shouldn't say finally, but we should try to learn some data visualization principles. So if I said to you, how many 7s are there here? You take a moment to try to count them. Well, if I'm being honest with you, I don't actually know how many there are. I think there's 14. That's what people typically call out. But how hard is it to count them now? Okay, and how about now? So this is what I was saying about the baselines when I was talking about titles being tilted. When we see things and understand them as baselines, they're actually, it's much easier for our brain to connect the dots. So if you take some time to learn some data visualization principles, which you should, and it's totally fun too, so it's not a dry subject at all, you'll see that there are things like this that actually help us comprehend information more quickly. And just as another example, if I said, look at this table and said, what is the second highest month according to the data, you'd have to go through each one and remember it and then compare it to the next one and say, is that one second high? Is that the highest? Is this the second highest? It's taxing. It works our memory. Or I should say it puts a tax on our working memory. If I turn it into a chart, it's actually very clear what the second highest month, and we can see it instantaneously. So this is why data visualization is very important, because it helps us condense large amounts of data into a very small space, and it helps us comprehend it very quickly. So what other things can we say about this chart? Well, we see that when the lowest point is, and we see when the highest point is. And finally, we even see there's some seasonality where it goes up, up, down, up, up, down. So this is stuff we can see actually very quickly. And if I remove these dates, and this was some other data set being displayed, whether it's 10 pieces of data or 1,000, if it looks like this, we understand rather quickly what's going on, what the highest points are and the lowest points and the direction of that chart. So the most important thing to remember with data visualization, as I've presented earlier, is what we perceive is not necessarily a function of what's there. So we need to connect our data visualization to our underlying message. So as a rule of thumb with data visualization, you should always try to match the underlying problem, as I said earlier. So this one on the right, we see that this is a line chart. Lines are used to show trend. So this is incorrect, because here we have apples, grapes, pears, and pineapples. There's no inherent trend. We're just trying to compare the different fruits that people like. So that doesn't necessarily make sense. So always try to connect what you're displaying to the underlying message. And finally, respecting the audience's intelligence. This is probably my favorite part. It's the part that we often kind of overlook. Because as a tendency as data scientists, analysts, business intelligence folks, business analysts, we want to make things that are complex sometimes because we want to show what we can do. But really, our work needs to be as complex as the underlying idea. We should always use charts that naturally present that underlying problem. And we should have confidence. That's our efficacy. So in creating work that is connected to the underlying problem, and it helps us have confidence and explain what we've done. We should use charts that we believe in. If management objects, at least show them the alternative. I know that sometimes you can't get away from those 3D pie charts. I get it. But at least show them the alternative, because that'll get them thinking, and it may plant the seed for the future, and they may ask you, as has been my case, to lead data visual efforts, and then you sort of become that person, or you become, you can set the tone for what the future is going to be and say, this is what we're going to use from now on. So don't give up. Ditch that advice that says to treat your audience like an idiot. Treat them with respect and show them what they need to show. That means don't make something 3D because you think they're too stupid to understand it without it. Make the chart that is connected to the message. And the same thing with clip art. Don't put that in there because you assume your audience is going to get bored. So going back to where we started in this presentation, the things that we wanted to emphasize were development memory. So remember, that's encoding what you've done. Model transparency. That's understanding what you've done and being able to explain and ask questions and dissect and unpack. And finally, model efficacy, and we focused a little bit on that at the end. You should have confidence in what you're presenting. If you can connect to your message, it's that much easier. If you treat your audience with respect, they'll believe in you and you can believe in them, and you'll be able to get a lot more across. And just going back to what we presented in those 3 buckets of layout and design and mechanics and data visualization presentation. So those are the 3 areas that I've presented to you. Maybe take some time and think in that last 20 or 40% of what you disagreed with me on or that I didn't necessarily cover, what are things that you can do differently? How can you make things better? So thank you everyone for listening to my presentation. The resources down below. Hopefully most of you know of Chandu. He writes a lot on data visualization. Perceptualedge.com, that's Stephen Few's site, and obviously check out excel.tv, and we talk about data visualization a lot there. And I'm happy to open it up to questions.
All right, Jordan, this is Thomas, and there are some questions excuse me, listed here. The first one came up right at the beginning when you were talking about layout. It said, will you talk about layout this out so it can move into Power Pivot? Do you understand that one?
Sure. So right now my work does not, or at least the work I'm presenting does not deal with Power Pivot just yet, only because what I've found is the organizations I've worked with don't have the means to use it. So I think Power Pivot is a phenomenal technology. It's very, very useful. But I can't really present in that way yet because even though Excel 2016 is here, most of the organizations I'm working with still use 2010 and are way behind on the Power Pivot curve. What I will say, though, is that Power Pivot does follow, at least in theory, it does follow what I'm trying to describe here. So the Power Pivot, you can connect it to some data source, and that data source remains untouched. And then on top of that, you can do some sort of transformations. So you can create different ways of looking up that information. Then finally, you can present it with a pivot table or a pivot chart, or there's, I think, Power View. Someone will point out my ignorance on that, but there's multiple different ways of presenting it. So it does actually follow the framework that I'm presenting here.
Okay, and the next one is, do you recommend a specific naming style from your experiences? And I think you've answered a lot of that, but he says that Power Pivot recommends no spaces.
Sure. So with Power Pivot, you know, I understand why they recommend no spaces because it's a database technology in terms of naming things, so that's very common. You know, I used to be very big on the spaces because what I saw in my own work, especially when I was doing work for the government, was that there were file names that were just junky. You know, they had all sorts of underscores, abbreviations, as you might imagine with the government. So I was trying to set a different tone and say, we're going to try to turn these into very descriptive terms. So here's what I'll say. I would say, rather than think of what you should try to do, just try to, let's think of the things that you should not do. So you should not use underscores or dashes. You should not use file names that look like engineering variables. So if you want to stick with the no spaces, as long as they're descriptive and they're short and they clearly describe what's going on, then I don't necessarily have a problem with that. I still like spaces, though. I'm not going to lie. So it's just really more about thinking, rather than think of what's the right way or the wrong way, just think about, you know, what does not work in trying to keep a record of my files and describing what they are and what they do.
Okay, and the next two kind of go back to your naming convention. One says comment is use a clear date. That would be 2016-08-16, and then he says, is 08-01 the 1st of August or the 8th of January?
Well, that's a great question. So maybe I didn't use a clear date, but I think I think that question demonstrates the right way to think about this problem. So you know, there's various ways to do it. You know, the organizations I work with are very clear on month, day, year. So it's the 8-digit one. I would say that if it's unclear, I personally don't like keeping the date in the file because there's a date modified dropdown. But if you must put it in there, and there are times when you must, I would say it's important just to keep to the convention and convey that to whom you're sending it to. And also just to sort of think in that way. I'm trying to think if there's a way around that that would make that easier, whether it's January 8th or August 1st. And maybe I think that's just going to depend on the culture of where you're working. So in America, we don't typically use the date DDMM, but I think that's a great catch, and it really speaks to the confusion around this.
All right, the next one's a comment. Great meeting you again, Jordan. This is a guy named Ali. He said he met you at an Excel VBA meetup in New York, but he doesn't have any questions, just wants to say hi.
Oh, awesome.
Oz made a comment, and no one reads the instructions. That's what you were talking about that.
No, that's, the funny part is no one's going to read it in the spreadsheet, and they're definitely not going to read it when you spend all this time in PowerPoint making them crazy good instructions. They're probably not going to read it, but they are useful when you're in the group and they ask you questions. You can pull them out and say, hey, click on this and click on this, and they might remember that.
Exactly, yeah. At least you did it, at least you documented
it. Yeah, it's true.
Someone made a comment at slide 31, why not a VLOOKUP?
Sure. So let's go back to that problem. And I assume, I'm not sure what the slide numbers are. Let's see here. Okay. So here's why I would, so first I would say there's nothing necessarily wrong with using a VLOOKUP here. But what I would say is it's probably not a good idea to use a VLOOKUP here, if only because if you're matching something. So it's only a function of this specific problem. So here I have product ID of 1, 2, and 3. Well, we know in record run 1 we want small, and we know in record 2 we want medium, and record 3 we want large. So it would not make sense to look up a 3 and match it to record item 3. We know it's already there. So really, if I was going to use a lookup function here, I'd use index, right? Because an index, we only need to provide it a row number. So using a VLOOKUP to match 1 to 1 doesn't necessarily make sense when I can just say I want something in the 1 position, if that makes sense.
Okay, the next one is a little lengthy. If need, to use today function in several expressions, will the file be more effective if I put today in a cell and refer to the cell? Will the only calculate today ones instead of in all cells, just in that first cell?
Well, sure. So great question. So in volatile formulas, all the dependents are updated. So generally speaking, it is a good idea if you require it to use it in one cell and pull from it. In fact, to make your life easier, you could put it in one cell, give that cell a name, like this is the current date or something like that, and pull from it from there. If you use it repetitively, it will slow things down. So it is a better idea to use it once, because even if the downstream updates in the calculations in Excel, so Excel makes a calculation train and makes it very efficiently when you open the file, even those downstream ones are probably less calculation heavy than repeating it multiple times. Another alternative is to use VBA to write the date to that point. And you can do that on the file open event. There's some issues with that. That can be, maybe you don't want to use VBA and you want something that doesn't have macros in it. But the point is, we should be thinking about these problems and ways around them.
Okay, isn't it better to minimize the use of spaces and tabs and ranges so that quotation marks are not necessary when referring to them?
They would only be necessary. Quotation marks would only be necessary if you are using indirect, which I would advocate you do not use, or if you are linking from one file to another, which you should. I would also advise staying away from that as much as possible because it's very buggy. I would say I have not had a problem with that because when I use formulas, I just click on the other sheet and the worksheet tab name reference is immediately available. It just pops up. So I rarely type in worksheet tab names from scratch. I would say if that is a concern, though, always remember named ranges allow you to shorten those things into a very consistent descriptive variable that you can use across the spreadsheet.
Okay, the next one, could you give an example of how index is easier to show than match or offset?
I don't know that index is easier to show. Offset, for whatever reason, is volatile. So I don't know why it's volatile. I don't know why Microsoft made it volatile, but it is. So generally speaking, index is a very fast function, and offset is less fast. The thing is about offset is I think it actually is more intuitively understandable at some points when you're developing your spreadsheet. So there is that trade-off there. I don't know. Really, to see the problem with offset, you need to use a lot of it. You need to use a lot of offsets in a spreadsheet, and I've made ones that have used a lot of offsets, and I've replaced them with index. And the best I could say it is much quicker. Charles Williams writes a lot on about that. So he's a Microsoft Excel MVP. I think he writes Fast Excel is the name of his blog, so he could probably speak a lot more to that because he's done timing on it.
Okay, and do you know who the father of pivot tables is?
I should, because I asked that as a as a challenge question in Excel TV, but I can't remember off the top of my head. But it is in one of Bill Jellen's books, so it's one of Mr. Excel's books. I just can't remember who it is.
All right. I usually have difficulty in selecting what I actually need to display in a dashboard, and I certainly have lots of options, which I believe make the dashboard look complicated. Any tip to reduce it?
Sure. So I think I'll tell you what I do. So what I do is I go to my audience and I have them outline for me the most important things that they want to see. So what I try to stay away from is this idea that it should be everything to everyone. So it's very common in dashboard development when people can't really agree on what it's supposed to be is to put everything on there and then it. But the effect of this is that we're making sense of data being read like tea leaves. It's just sort of scattered all around the place, and we're just drawing these nebulous conclusions that we don't necessarily know are true. So I guess for me, what I do is try to identify the message first, and then once I have about three to five bullet points, I try to outline what data I can use to support that, and then I think to myself, well, how would I present a support of that? And that tells me whether I want to use a chart or a table. And then the other thing is, if you develop in the way that I'm presenting here, you can actually change things very quickly. So also just keep in mind it's an iterative effort. You probably aren't going to get it right the first time, and in a certain sense you'll never get it right because it's a continuous improvement. So the best I can say is try to trace what you're doing to the audience and message of the dashboard, and then understand that you may have to make some changes later. Luckily, rapid design is one of the best features of Excel, that you can make changes quickly.
All right, that's going to be the last question we can take. You want to go ahead and flip the slides, and we're going to have to end this session. So thank you for attending. Next. And what we want to do is tell you this Thursday at noon, as well in the next 3 hours, there's going to be other presentations. If you go to our website, excelbivc.sequelpass.org, you'll see the links to the next 3 in the next 3 hours. But coming this Thursday, our regular monthly meeting is Devin Knight presenting on using Power BI parameters and templates. It's at noon Central, and you can go to the same website to register. Again, thank you for attending this session. Thank you, Jordan, for presenting.
Yes, thanks everyone, and make sure to check out the other presentations coming up here soon.
Yes, yes, please stay online. Well, it's not this, you'll have to exit this webinar session and go to the next one if you are attending one of the following ones. And again, this session is going to be recorded, so the recording will be up on our website, which is usually on our YouTube channel, probably within 2 to 3 days. Thank y'all.